Hello, my name is Sergio García, and today I'm presenting our study, Robotics, Software Engineering, a Perspective from the Service Robotics Domain. To conduct the study, we interviewed 18 industrial practitioners from 15 companies from 9 different countries. We complemented this data with an online questionnaire that yielded 156 answers. We could track 94 of these responses, 72 of them corresponding to industrial practitioners, whose demographic distribution is depicted at the right of the slide. In the study, we identified the most common practices applied in robotics. Roboticists mostly perform implementation and real-world experimentation as activities, for which they mainly follow agile software engineering processes. To develop robotic applications, they apply object-oriented programming and component-based software engineering paradigms and use C++ and Python as programming languages. Regarding quality assurance, the most used techniques are integration tests and code reviews. The most commonly reused artifacts are source code and libraries. We also infer the distinguishing characteristics of robotic software engineering, being the most repeated ones that robots is very cyber-physical in nature and the heterogeneity of disciplines that are required to develop a fully working robot. Finally, we identified and then surveyed a list of the most common challenges robotics is faced. Among the most problematic are achieving robustness for robotic applications, validating them, and make them to dynamically adapt. The most common solution according to respondents is performing rigorous test processes involving real-world testing. And another pressing challenge is the lack of documentation of software packages, which is addressed using reviews, wikis, guidelines on comments, and automatic generation of documentation. Finally, as takeaway messages, during the study, we identified the need of enhancing robustness of robotic applications, for which they require real-world testing processes. We also learned that simulations are often decoupled from the real world, and that systematic integration and reuse are complicated due to the huge variability of tasks, hardware, and environment.